All right, let's go ahead and continue on. We're now on page 12, and we're doing D, E, and F, and then we'll go to page 13. Okay, now we're going to be dealing with multiple translations or transformations. One thing that I do want to note is that we always want to flip first. So when we're flipping over the X or the Y, we always want to go ahead and flip that first. And then if there is a binomial, right, we want to go ahead and factor out the negative with our binomials. And this will come in handy in a little bit, but just make note of that. Okay, so if I'm looking at part D, it looks like we're dealing with two transformations, right? We see that this negative is attached to the X. So we're actually going to be, we're actually going to be going ahead. Come on, pen, don't die me now. My goodness gracious. Good. All right, we're actually going to go ahead and first flip over our y-axis. And then that second transformation, we're going to go ahead and go down 2. So our parent function is, again, y is equal to 2 to the x power. So this is our parent function. The first one is we're flipping over the y. So this is what we're going to look like. And then we're going to go ahead and move it down 2. So there's my point right there. And there's my point right there. Moving down 2 means that we're moving our y, our horizontal asymptote, to y is equal to -2. So I can go ahead and say y is equal to a -2. And this is what our graph looks like. Okay, our domain is still -infinity to infinity. Range is now going from a -2 to infinity. The x-intercept changes. We actually do have one. It's at -1, 0. And our y-intercept is at 0, -1. Okay. Part E, this is when we might have to do some factoring, right? We see that binomial, and it's a rule of thumb that if there's a negative attached to it, we do have to factor it out. So I'm going to go ahead and rewrite this one. We're dealing with y is equal to 3. I'm going to factor out the negative. It becomes x minus 2. And now we can go ahead and see what we're going to be doing to our graph. So this one, we're going to go ahead and flip over the y-axis now. And then it looks like we're going to go right 2. So now our parent function is really 3 to the x power. So this is our parent function. I'm going to go ahead and flip over the y-axis first. Looking like that. And then I'm going to go ahead and take it to the right 2. And this is what we look like. Okay, we do not have any transformations going up or down, so we do still have a horizontal asymptote at y is equal to 0. Our domain is still -infinity to infinity. Range is still 0 to infinity. The x-intercept, there are none. But now I can't just eyeball and say, okay, like that's 8. Like obviously cannot do that. We might have to do some extra math to find the y and the x-intercept that time. So in this case, I'm going to go ahead and try solving for the y-intercept. That is just like what we've done in the past. You're going to go ahead and plug in 0 for x. So we get y is equal to 3 to the -0 plus 2. This becomes 3 squared. So then we have 0, 9 as our y-intercept. And you are done. Go ahead and try part F on your own. I will pause, go ahead and pause the video and then return when you are ready. All right, we got multiple things going on right here. So we set up here, right, if it is not attached to the x, we're flipping over the x-axis. So this first negative is flipping over the x. And then this one that is attached to the x, this is actually going to be flipping over the y. So in this case, we are going to go ahead and flip both. And then we are going to go up 1. It looks like our parent function is still y is equal to 3 to the x power. And this is what it looks like. Flipping over both, I'm going to go ahead and flip over the y-axis first. So that's like this guy. Okay, and I'm going to go and flip it over the x-axis. And that looks like this guy. And then you can go ahead and move everything up 1. So then it actually looks like this guy, where you have the horizontal asymptote now at y is equal to 1. Horizontal asymptote, we have y is equal to 1. Domain is still negative infinity to infinity. Range is now from negative infinity to a positive 1. There is an x-intercept, right? It's at 0, 0. There is a y-intercept at 0, 0 as well, and you are done. That is just our simple transformations with our exponential functions. Going now to page 13, we're going to be dealing with the letter E. So there's a story behind it. In 1741, the Swiss mathematician, Mr. Euler, introduced the letter E to represent a certain irrational number that lies between 2 and 3. So you guys have seen this on your calculators since like day 1. So go to your calculator. And then you're going to go ahead and find where E is at. I'm going to go ahead and select second E, press enter, and you see that we get 2.718281828, right? E is just a number, it's just a value. And so I'm going to go ahead and round it to 3 decimal places. We're dealing with 2.718, and that's what E is. So since E is between 2 and 3, it is reasonable to predict that the values of the function y is equal to e to the x power will be between y is equal to 2 to the x power and y is equal to 3 to the x power. So in example 2, it's asking us to go ahead and graph these 3 functions together on the same plane. So if I was starting with, let's do this guy, y is equal to 2 to the x power. You guys already know this. We just did this. There is my y is equal to 2 to the x power. Let's do 3 to the x power in blue. There is that guy right there. And now we can go ahead and incorporate our new function of y is equal to e to the x power. Right, we just found out that e is this 2.718. If I was looking at my graph, that's like right here, 2.718. Right, and then I can go ahead and take that point right there, because it's still the same. If I have e to the 0 power, that just gives me e. So there's my 1 point of 1 and e. So that is right in the middle of those values. Ta-da! There's your proof. Alright, so example 3, we're going to go ahead and try graphing some of our functions that deal with e. So in example A, it looks like we're just dealing with going right 1. So your parent function is going to be y is equal to e to the x power. And that is this guy right there. And again, you're just going right 1. So then there is your function. Okay, we're still dealing with a horizontal asymptote at y is equal to 0. Nothing changes there. Oh, I probably should have added that up here. Sorry, guys. Y is equal to 0. So again, you have your horizontal at y is equal to 0. Domain stays the same. We're dealing with a negative infinity to infinity. range is at 0 and to infinity again. There are no x-intercepts. And now for the y-intercept, I can't just say, okay, call it a day. Let's say it's 0, 1. Right? I cannot just go ahead and just assume that. This is where you're going to have to do some of additional math. But you guys are smarty pants, so. Alright, again, plugging in 0 for x, I get e to the 0 minus 1. This becomes e to the negative 1 power. And I can turn that into a fraction of 1 over e. So your y-intercept is going to be 0, 1 over e. Alright, part B. This one, it looks like we're going to go ahead and flip over the x-axis. And then the second transformation, we're going to go up 1. So again, your parent function is y is equal to e to the x. That is somewhere around here. I'm going to go ahead and flip over the x-axis first. So that is like this guy. And then I'm going to go ahead and take everything up 1. And your new horizontal asymptote is at y is equal to 1. And this is your new function. So domain still stays the same. We have negative infinity to infinity. Range is from negative infinity to now 1. Your horizontal asymptote did change. We're at y is equal to 1. And it looks like our x and our y-intercepts are at 0, 0. Alright, go ahead and pause the video. Try doing C on your own. Just try it. Alright, so it looks like the negative in front of the e means that we're actually going to go ahead and flip over the x-axis. Looks like we're going to go ahead and go left 1, and then we're going to go ahead and go down 2. Again, your parent function is e to the x. There's that guy. I'm going to go and flip over the x-axis first. Yada, yada, yada. Right. I'm going to go ahead and go left 1. Let's do it in blue. Left 1. There's that guy. It's getting messy. And then I'm going to go ahead and go down 2. So what is that? Going down 1, 2. Uh-oh. Hold on. There you go. And there is that graph. Again, since we went down 2, your horizontal asymptote did change. Where y is equal to a negative 2. Golly gee, pen, do not die on me now. Final stretch. Literally. Okay, so we have the horizontal asymptote at y is equal to a negative 2. We have a domain of a negative infinity to infinity. Oh my goodness gracious. Right, our range is now going from negative infinity to a negative 2. The x-intercept, there still are none. And the y-intercept, I can't just eyeball it and say that's, okay, negative 1, negative 2, negative 3. Negative 4.56 bajillion 7, right? You can't go ahead and do that. You're going to have to do some extra math on this side. Again, plugging in 0 for x, I get y is equal to a negative e. 0 plus 1 minus 2. This gets me negative e to the first power minus 2. Just negative e minus 2. So you have 0, negative e minus 2. And you are done. Yay!